Behind my smile, I'll say whatever you want, let you walk in.
Welcome guys to today's class. In today's video, we want to discuss another important experiment in practical physics, and that is experiment on obstructed simple pendulum. In this experiment, we will see what we mean by obstructed simple pendulum. It has this objective, apparatus setup, procedure. Yes, let's see. Objective: to determine the relationship between the periodic time t and the length y of the points of a simple pendulum allowed to oscillate. Look at the apparatus setup. The retor stand on a what? On a desk. This is a desk. A table or desk. Then look at the thread holding the pendulum bulb. This is the bulb. Look at the meter rule you will use to take your measurement. Look at the thread. Look at the spill cork. Now, when you use this to perform your first experiment, you will also use it to do your second experiment by following step 2. We will still discuss it. And look at the movement it will follow, the direction of movement it has to follow, to and flow. And this is the stopwatch that we use to take our time. Okay. Step 1. Set up the simple pendulum with length L equal to 100 cm or greater, with knife edge mounted at the edge of the table. You set it up with the length L equals to 100 centimeter. Then oscillate the whole pendulum and determine the periodic time TL by timing 20 complete oscillation twice. What it means is that we displace it at a small angle. We'll displace this thread at a small angle so that it will start oscillate for 20 oscillations. And we will do it 2 times. Afterwards, shift the stand away from the edge of the table until y equal to 40 cm. You have to shift this stand away. And so when you shift this stand away, it will get to a point that this thread will be touching this table. This thread will now be touching this table. Are you getting it? So what you now do is that point is touching the table. You have to hold it there. And make sure that only from here to here is now oscillating. And that distance from here to here for the first one will be 40 cm. It has to be 40 cm. How do you get the 40 cm? If your thread is not too long, what you have to do is that you lower this your retort stand. Okay, so once you're able to lower this retort stand, it will make this rope to be longer. And so you need a higher table or desk to keep this retort stand and perform this experiment, so that when you lower it, as the rope is going to be longer, it will not be touching the ground. Are you getting it? It still be hanging. The reason why you have to lower it is so as to be able to get your 40 cm when you shift this retort stand inside and clamp this thread, clamp it at this at this edge of the table. When you clamp it, this part up will be stationary. They will not be moving again. Only this part down will be willing to oscillate or to move to and fro motion. Are you getting it? And so that point you clamp till down, you have to measure 40 cm first. Do the experiment 2 times, measure 35, do the experiment 2 times, measure 25, and so on. Are you getting it? So It's very important. So as you are performing this experiment, you have to note precautions, very important. And these precautions we talk about, whether you are asked to include your precautions or not, whatever experiment you perform in physics, if you are not told, know it now that you have to put precautions. You take note of why what performing that experiment. And so at least 2 precautions have to be what noted down. So one of the precautions I'm giving you for this experiment is to make sure that your angle of displacement, the angle, look at the rope, the angle you have to displace the bulb, pendulum bulb, so that it will be moving to and fro. You make sure that that angle is very small. That is what we say, less than 10 degrees. To tell you it's very small. So that once it is very small, it will be able to be moving to and fro slowly, and you'll be able to get your 20 oscillation accurately. Noted? So you say, care was taken by why displace my angle. By what? Displacing it at very small angle. Care was taken while displaying my what? Pendulum bulb, by ensuring that it is displayed at very small angle, so as to minimize what? Error. Yes, because when you're able to get the exact time, you are minimizing error. Another precaution you can talk about in this experiment is that the doors and windows and electric fan were what? Switch off. You close your windows, you lock your door, you switch up the what? Electric fan, so as to reduce air resistance. Once the air is interfering in the experiment, it will affect the time you have to get for your what result. Are you getting it? It will affect it. And you have to also note again that meter rule was used. So error due to parallax is also avoided by making sure that I take my reading vertically downwards from the meter rule. You note that one. This clamping of this point, so at this point we oscillate, I make sure that this thread is clamped tightly on this edge of this, so as to what? Enable this to what? Oscillate perfectly. Are you getting it? So you have plenty errors to precautions to what? Talk about in this experiment. Now this is a stopwatch, and this is the extension diagram we talk about. Now the essence of performing this experiment is to teach you how to run this experiment without touching apparatus. Yes, we want to see how to do it without touching apparatus. Now to be able to get your table of values, you just need your calculator. Yes, very important. First thing we have to do is to recall that period is equal to 2 pi root what? L over G. Period is equal to 2 pi root L over G, where L is equal to 100 cm, G is equal to 980 centimeter per second squared. Yes. And so I will put it here, and I will be having T, that T for length. Period for this length is equal to 2 pi root what? 100 over 980. Okay? Let's use a calculator. 2 shift pi root bracket 100 divided by 980. That will be giving us 2.0071 approximately. That is in seconds. So if I'm to get my TL squared, I will have to square the value, square it. We'll be having 4.028. 4.028 seconds squared. So I have to note it somewhere that my T L squared equals to 4.028 seconds squared. My TL squared equals to 4.028 seconds squared. That is the first thing you have to do. That is for this your first experiment, so to speak. For the second experiment, you recall that this step 2 is vividly for this experiment. This table is focusing on this step 2. Yes, because once we are able to get all this, we are able to get this perfectly. Now, we also say that period for y is equal to 2 pi root y over g. Since we say period for length, equal to 2 pi root L over G. Period for y will be equal to 2 pi root y over G. Are you getting it? And so, we will say that Ty will be equal to 2 pi root, the first one is 40 all over 9/8. After that, you do the one of 35 all over 9/8. You do the one of 30 all over 9/80. Like that. Let's check it. 2 shift pi root bracket 40 divided by 9/8. We'll be having it to be equal to 1.2693. We have it to be 1.27 seconds. Yes, you change here to be what? 35. You change it to be 35. You say 2 shift pi root bracket 35 divided by what? 9/8. That will be giving 1.19. You change here to be 30. You say 2 shift pi square root bracket 30 divided by 9/8. You'll be having 1.10 seconds. Then you do the one of 25. 2 shift pi root bracket 25 divided by 9/8. You'll be having 1.00 seconds. You do it again for the one of 15. 2 shift pi root bracket 15 divided by 9/8. You'll be having 0.78 seconds. You do the one of 20, the one of 10. 2 shift pi 10 divided by 9/8. .63. You have 0.63 seconds. So after you have gotten your Ty, after you are done with your Ty, you put it here. You say 1.27, 1.19, 1.10, 1.00, 0.78. So this is for what? 40.00, 35.00, 30.00, 25.00, 15.00. So we're able to get our y, which was given to us, and our Ty on our what? Table. Are you getting it? So we have packaged our y and our Ty on the table. Now to get our Ty squared, we will tell them that we will start squaring everything. 1.27 squared. That will be giving you 1.61. 1.19 squared. 1.42, 1.1 squared, 1.21. 1 squared is what? 1. 0.78 squared, 0.61. 0.63 squared, 0.40. Okay, that is about your ty squared. But you can see this tm. This tm mean of the time you got for t1 and t2, mean of their time. Okay, so look at how to get it. You tell them that t1 plus t2 all over 2 is equal to tm. Therefore 2tm minus t1 equals to t2. 2 times this 2tm minus t1 equal to t2. Are you getting it? Now how do you get your tm? Remember that period is equal to number of all over what? Time takes to what? Period is equal to time all over n. I try to remember some formula. Period equals to time all over n. Also, now that time we'll call it tm, mean of the time. Therefore, mean of the time will be equal to n times the period. N is 20. So what we have to do is to use 20 to multiply all this our what? Ty. 20 times 1.27 will give me 25.4. 20 times 1.19 will give me 23.8. 20 times 1.10 will give me 22.00. 20 times 1, 20.00. 20 times 0.78, 15.60. 20 times 0.63, 12.60. You have gotten your tm. Now, because you are performing experiment on simple pendulum, and we have to see how to get it without what? Touching apparatus. What you have to do for your T1 and T2, note that whatever you add to T1, that is what you subtract to get your T2. Whatever you add to get your T1, you subtract it to get your T2. Now, with experience, I will tell you, for your T1, add 1.5 to it, to this your Tm, and what? Subtract 1.5 from your Tm. That is just it. If you say add 1.0, you have to say subtract 1.0. Are you getting it? But look for a number that can go well. 1.5 can go well in this simple pendulum experiment. And so that is how we'll get it. We will add 1.5 to 25.4. 25.4 plus 1.5. That will be giving me 26.9. I will subtract 1.5 plus from 25.4. It will give me 23.90, right? If you take the mean, it will be giving you this. Let's check. 26.9 plus 23.9 divided by 2. It will give you 25.4. That is the implication. Do same for the next one. 23.8 plus 1.5. What will it give you? 25.3. 0. 23.8 minus 1.5, 22.30. 22.0 plus 1.5, 23.50. Then 22 minus 1.5, 20.50. You go again, 20 plus 1.5, 21.50. 20 minus 1.5, 18.50. 15.6 minus 1.5 will be equal to 14.10. 15.6 plus 1.5, 17.10. 12.6 minus 1.5, 11.10. 12.6 plus 1.5, 14.10. You have noted that. Then t square. T square means subtract your TL. T squared L minus t squared Y. We'll start subtracting this and each of this. Okay? We say 4.028 minus 1.61. 4.028 minus 1.61. That will be giving you 2.42. 4.028 minus 1.42. 2.61. 4.028 minus 1.21. 2.82. 4.028 minus 1. 3.03. 4.028 minus 0.61. 3.42. 4.028 minus 0.40. 3.63. Okay? So we have gotten our table of values for this experiment, and next is for us to see graph plotting, where we'll plot the graph of t square against y. T square against y. The unit of that t square is what? Second squared. That is the unit. Okay? Graph of t square against y. Still keep in touch with our channel to see the graphical aspect of it.